Okay, so we need to look at these examples real quick. So find the vertical asymptote. So in order to find your vertical asymptote, we are looking at these. So we need to find out what our x's cannot be, and then as long as they don't cancel out, those are vertical asymptotes. So on this, x can't be 0, but we can cross those out. So actually it's x plus 4 equals 0. So x equals -4 is our vertical asymptote. Okay, the next one is our, well, I guess we could draw a little vertical asymptote. 1, 2, 3, 4, -4. So this would be our vertical asymptote. Okay, the next one, find the vertical asymptotes, if any, of the graph of this rational function. I cannot make this ever equal 0. So there are no vertical asymptotes, because x squared plus 4 will never equal 0. Because if you end up solving this, that'll never happen. That's imaginary. Okay. And then for A, find the horizontal asymptotes, if any. So we need to do our horizontal asymptotes. So we would look at our leading coefficient, and they have the same degree. So our horizontal asymptote would be y equals -2/3, because you take your coefficients. So let's say this is -1, so -2/3 would be like right there. And it's horizontal, so it's a horizontal line. This is at y equals -2/3. Okay, let's do the next one. We are doing horizontal asymptote again. So let's see. This one is smaller than this one. So if we look at our notes, if this one is smaller than this one, the numerator has a lower degree than the denominator, then y equals 0 is your horizontal asymptote. So y equals 0. J. So we would just do like this. Y equals 0. Okay, pencil problem. So whenever y'all do y'all's assignments, you need to make sure that you are actually writing things out, because you're going to turn in the assignment. Your work from the assignment. So use the graph f of x equals 1/x to graph this. So yesterday we didn't get to finish our notes, so we're going to finish those right here. So graphing rational functions, we are going to look at how it transforms from f of x equals 1/x. And here's our transformations. So A is your vertical stretch and compression. I'll let y'all copy that down. And then H is what moves it horizontal, left and right. Okay, so it'll go either left or right. So left, if H equals negative number, and it'll go right if H is a positive number. And then K is going to be our vertical shift. So up is whenever K is positive, and down is if K is negative. Okay, so on here, we don't have any stretch or compression, but when we look at f of x equals a over x minus h plus k. So we got k and we got h. So H is your horizontal shift. So shift. It's supposed to be X minus H. So H in this case is going to be minus -1. So it's going to be a shift left. 1 unit. And then K is going to shift down 1 unit, down 2 units. So from our original function, remember that most basic function that we wrote out in our notes, these, it's going to keep the same shape, but shift 1 unit over and 2 units down. So I'm actually going to draw it on here. So over 1, that means that this is going to be -1 and down 2. And so your function's going to look the exact same because A was not changed. Something like this. It's a rough graph. And you could find out for sure by plugging in X and Y and filling out a table. Okay, so in comp book. Okay, the next one, we need to graph this negative X over X plus 1. So let's go ahead and find our asymptotes and our intercepts and everything like that. We need to check symmetry. So we are going to check and see f of -x equals f of x. Okay, so if I plug in a -x, I'd have -x equals -x plus 1, which equals a positive x over -x plus 1, which if I pull out a negative, then that's going to change this, but this is going to be like that. So that is not going to work. Okay, so it does not have symmetry. Okay, so then we check for our y-intercept. Y-intercept is whenever x equals 0. So I'm going to do f of 0 equals -0 over 0 plus 1, which would equal just 0. So our y-intercept is at 0. And then we need to see about the vertical asymptote. So it'd be x plus 1. Nothing can be canceled, so equals 0. So -1. So x equals -1 is where we're going to have a vertical asymptote. Okay, and then horizontal asymptote. If we do f of x equals -x over x plus 1, these are the exact same. So your vertical asymptote would be at -1 over 1. So y equals -1. So those are our two asymptotes. So we'll graph those in our journal. And then we might have to use a table of values to find some more points. So I'm going to go over to my composition book. Go here. It is, let's see, let's do our x and y axis. So this is at, we have a y-intercept at 0, so that means the origin, 0, 0. And then we are going to do a vertical asymptote, so the vertical one's at -1. And then our horizontal asymptote is at -1. Okay, and then we just need to know how it's going to look. There is this negative out front. So we need to, let's see, plug in some points to find out how it's going to be done. So we know 0, 0 is there. So let's plug in 1. So if I plug in 1, I do, it'd be -1 over 1 plus 1, which equals -1 over 2. So over 1, down half. Okay, so it looks like it's going down. It's going to continue to increase. So that means that if I do probably -1/2 would be -1/2 over -1/2 plus 1. So I'm going to put that in the calculator. -1/2 over -1/2 plus 1 equals -1. So -1/2 at -1, so it'd be like that. So this is what one side of it looks like. Okay, and so then the next side, I bet you it's going to be over here, but let's check. -2. So it'd be -2 over -2 plus 1. Okay, let me pause this real quick. Okay, so let me finish this now. So whenever we plug in the -2, we get 2 over -1, which is -2, which is what I predicted right there. So it's going to get closer here and closer there. But to show that, we do 1, 2, 3, -3. And so you do -3 over -3 plus 1. So +3 over -2. So -3 over 2, which is -1/2. Down -1/2. So it's going to follow the same pattern. So okay, let's do 6B. We need to see if we have some symmetry first. So we are going to do f of -x. So that means I'm going to plug in -x for x. But whenever you square something, it becomes positive. So it looked just like that. Okay, so this means it's going to have symmetry over the y-axis. Okay, let's check the y-intercept. So f of 0 equals -1 over 0 squared minus 4, which equals -1 over -4, which would be positive 1/4. So when we graph it, we are going to, our y-intercept is at positive 1/4, so it'll be right about there. Okay, so let me find the vertical asymptote. So that'd be when x squared minus 4 equals 0. So you could factor these or you could solve it, but this could be factored as x plus 2 and x minus 2. So then if we solve this, x equals 2 is a vertical asymptote and x equals -2, vertical asymptote. So we did the x-intercept, we did the symmetry, vertical asymptote. So at positive 2 will be a vertical asymptote, x equals positive 2, and then x equals -2. Okay. And then we need to know about our horizontal asymptote. And we don't have any, so we have an x to the 0 over x squared, so this one's greater. So when the numerator is less than the denominator on the exponent, that means y equals 0 is our horizontal asymptote.
Anybody that dressed up today for costume day, please make your way out to the foyer.
This is y equals 0. Oh, thank you. Okay, so that's what it looks like right now. So now we just need to plot some points so that we can find what it actually looks like. So let's see. X, Y. Okay, so we know we have 0 and 1/4. It's right here. So let's see what 1 will be. So if I plug in a 1, that'll be negative 1 over 1 squared minus 4 equals negative 1 over 1 minus 4 would be negative 3. Negative over negative makes that 1/3. So this was 1/4, so 1/3. So, and it's going to have symmetry, so this way it's going to go like this. So it's going to look like a quadratic parabola. Okay, because we know it has symmetry and it can't go across this. So now we need to find this one. So let's see. 1, 2, 3. Let's do negative 3. So negative 1 over negative 3 squared minus 4 equals negative 1 over, that'd be 9 minus 4, which would be 5. Negative 1/5. So over to negative 3, down to 1/5, so it's like that. So this is going to be the same thing because it has symmetry. So it's going to curve to the side and curve to the side. So that's what your graph should look like. Okay, number 7 is find the slant asymptote. So to find our slant asymptote, if the degree of the numerator is 1 greater than the degree of the denominator, then there's a slant asymptote and we divide them. And this would be our slant asymptote when we drop off the remainder. So this is greater than this one. So that means we have a slant asymptote. We're going to divide it. So x squared plus x minus 6, divide it by x minus 3. Okay, so x into x squared would be x. So that'd be x squared minus 3x. And we subtract them. So that would be 0, and this would be 4x. Carry down to minus 6. Okay, x into 4x would be plus 4. 4 times x is 4x. 4 times a negative 3 is negative 12. Subtract them. Those become 0. This becomes a positive 6. So when we divide it, this actually comes out to x plus 4 plus our remainder, 6 over x minus 30. So then this would be our slant. So it would be y equals x plus 4. So the way that you see a slant asymptote on the graph is as a linear function with this one is a positive slope. So it would be your y-intercept is positive 4 and your slope is 1. So your asymptote is like this. So your function will not cross this or touch this. So this is your y equals x plus 4 slant asymptote. So it could be a negative asymptote if it needs to be. Okay, and that is all the notes that we will do. We don't have to do any of these. So once you finish your notes, then you are going to do the assignment in Pearson and make sure you show your work so that you can get credit. You will be turning in your work this time. Make sure you're not just using the calculator.